Everyone, myself Saurabh Saraswat, and today we are going to discuss a LeetCode problem number 447, that is number of boomerangs. It is basically a medium level of problem. So let us discuss it. So the problem says that you are given n points in the plane that are all distinct, where points of I equal to xi, yi. So basically it is saying that there is an array with a name of points, and at each index of that particular array there will be a list which consists of two elements, that is xi or yi, or you can say it as there will be a x coordinate or y coordinate of that particular point. Okay, so let us read the next part of that question. So here it is given a boomerang is a tuple of points I, j, k such that the distance between I and j equals the distance between I and k. The order of the tuple matters. So what that means actually? Okay, so let me explain you here. So here you can see, let's say we have 3 points I, j and k. So basically these will be called a boomerang. Basically 3 points will be called as a boomerang if and only if the distance between the ith, means the point, one point, I point to the jth point, will be equal to the distance between I and k. Okay, here I, j, k is basically a point which having two coordinates x and y. So each I, j, k have two coordinates x and y, and the value will be different. Okay, so basically what the boomerang is, the distance between I to j will be equal to the I to k. There is one more thing here we have to notice, that is if we have I, j, k and the other one we have I, k and j. So these two will be considered as two boomerangs, not a single boomerang. Why? Because it is mentioned here the order of the tuple matters. Okay, means ijk is called one boomerang, but if we shuffle the values of other elements other than the pivot element, here the pivot element is I because we are checking the distance of other element from I. So if we change the distance of other elements from this I, if we shuffle the position of other elements, let's say here jk and here kj, so these will become a new boomerang. Okay, so these both will be counted as different boomerangs, so the total count will become 2. Okay, so let us see the example cases what is given here, and we have to return the number of boomerangs basically in this question. Okay, let us see the example. Here in the example there is a list given 0 0 1 0 2 0. So we have to the output return is 2. Basically it means there are two boomerangs. How it will be 2? Let's say let's find the distance between 0 0 1 0, that will be 1. Let's find the distance between 0 0 and 2 0, so that will be 2. Okay, so the distance between this point to this point is 1, and from this point to this point is 2, so it cannot be the boomerang. Okay, so let us make the ith point as 1 comma 0. Okay, from I1 comma 0 let's check the distance of 0 comma 0, that will be 1. From 1 comma 0 let's check the distance of 2 comma 0, that is also 1. So basically if I make a I point as 1 comma 0, then it will become one boomerang. Okay, so here you can see if 1 comma 0 is the ith value, means ith index, here you can see the first one was ith. Okay, if it is the ith point, then j and k, then the other points we can make a 1 comma 0 0 comma 0 and 2 comma 0 as a boomerang. Okay, and I also told you that j comma k and k comma j, if I shuffle both the position, then it will become a new boomerang. So here you can see 0 comma 0 2 comma 0 and 2 comma 0 and 0 comma 0, basically we shuffle the position, so it will become two boomerang. Okay, so that's why the answer is 2. If I check the case of 2 comma 0, so the distance of 2 comma 0 and 0 comma 0 is basically 2. The distance of 2 comma 0 and 1 comma 0 is basically 1. So the distance are not same, so basically it can't make a boomerang. So let us come on to this case. If we check the distance of 1 1 comma 1 to 2 comma 2 comma 2. So here you can see it will be under root 2 minus 1, basically it will be under root 2. If we check the distance of 1 comma 1 with 3 comma 3, it will be 2 under root 2. Okay, basically that will not be equal. Similar the case for the 3 comma 3. If we check if we make ith point as 2 comma 2 and check the other distance, let's say from 2 comma 2, the distance of 1 comma 1, that will be what? That will be under root 2. Similarly, let's check the distance of 3 comma 3 from 2 comma 2, that will also be under root 2. So both the distance are same. If we make 2 comma 2 as the ith point, so there will be two cases, 2 comma 2, 1 comma 1, 3 comma 3, and we shuffle the j and k point, that is 2 comma 2, 3 comma 3 and 1 comma 1. So basically there are two boomerang. Next example, that is 1 comma 1. Here you can see there is here it is only 1 point given, so we can't make a boomerang with only 1 point. Okay, so that's why the answer is 0. Okay, so let's see the constraint. So constraint is given that and the value of n can goes up to 500, and the point size length is equal to xy can go from minus 10 to the power 4 to plus 10 to the power 4. Okay, let us move on to the solution. Just to make some intuition, let us think it from the scratch. Sorry. Okay, so what like just think it from the sketch. If I want to just find this 3 point in which one is the pivot point, or you can say the ith, from one we say the I point, and from that point the other 2 points distance should be the same. So what we can do as per the code, okay, so we can we can use some for loop. Okay, so what it will do, this is our first for loop. So it is to fix the ith point, okay, whatever that is, from what we are seeing the distance. Okay, we are seeing the distance from ith point to j and ith point to k, so that is fixed by this first loop. Okay, then let's say here you can see, let's say the ith point is p1, and we check we fix this point p1. Now we are checking the distance of p1 with p2, and let's say the distance is 8. Okay, and now what I will do, I will find the third point which will be having the same distance. Okay, so what I will do, I will check it. Let's say the p4 have the same distance with p1, that is 8. Okay, so this is the first case. Now what I will do, I will choose the second point, that is from p1 to, I will choose the second point, that is p3, and I will check the distance. Let's say it is 4. Then what I will do, I will see what are the points having the distance 4 from p1. Let's say p5 have the distance. Okay, I will check and see. Let's say p5 have the same distance from p1. Okay, so basically this is the scenario how it is working. So the first loop is fixing the ith element. Okay, so this is the first loop. Now we are iterating over the second element, that is p2, p3 in this case. So for that we want for loop again, so that is the second for loop. That second for loop is for what? Fixing the second element, and for fixing the second element we find some distance. Let's in this case here we find the distance 8, and as per this distance we find the other third element that have the same distance from this p1. Okay, so that is for that, to find the third element we need to go through, or you can say we need to iterate with the use of the third loop. Okay, so here you can see we are moving over 3 loops. Okay, and 3 loops that basically iterate over the whole length. Let's say the length of an array is n, so it will iterate over n. Basically it will go n times, it will also go n time, it will also go n time. So the time complexity will become so high that will go so the time complexity will become n and inner loop, and then that also have inner loop, so the time complexity will become n to the power 3, basically n cube. So these time complexity is too much high because we have inputs of 500. Basically the array length we have 500, so the 500 to the power n cube, sorry, the 500 to the power 3 will become so high. Okay, so it will be so costly algorithm to find number of boomerangs. So let us simplify it. Okay, so what we can do to simplify it, let's think over it. Okay, so let me clear this first. Okay, so now here till this what we discuss what boomerang actually is. Now let us discuss what we can do to solve this in a much easy way or a simpler way. Okay, so for that what we can do, we can use hash map, or you can say in Python a dictionary. Okay, so what we will do, we will fix some point. Okay, we will fix some point and we will find the distance of other points with respect to that point. Okay, let's say here are 3 points I, j and k. Okay, what I will do, I will fix the first point and I will find the distance of k, distance of j. Okay, let's say they are 1 2 3 4 5 5 elements. So what I will do, from the first point, there are 5 points. Basically this point represent x y coordinates. Okay, so what I will do, I will find the distance of this, distance of this, distance of this, distance of this, and when I am finding the distance, I will maintain a map. Okay, so what I will do, I will check that is there a element with the same distance is present or not. If there is no element with that distance, then it's okay, then just create new entry and put the value as 1 because we found one element. Okay, here in the example, here you can see the upper example, you can see from p1 to p2, let's say our fixed point is this. Okay, this is our fixed point. Okay, and from the fixed point we are finding the distance to p2. Basically we found it as 8. So what I will do, I will make an entry of 8 and a value 1. Okay, now we will check the distance of p1 to p3. Okay, what we will found, we found the distance of p1 to p3 is 4, and we have that particular one point having the distance 4 from p1, so we will make an entry 4 and the value 1. Okay, now the in the third distance, that is from p1 to p4. So what the distance of p1 to p4, that is 8. So what I will see, I can see in what I can see in the map that 8 is already present. So what I will do, I will just increase that. That means I found two elements, means the one is there, means I already have one element with a distance 8, and I found another element. So what I will do, I will just increase, that is from the previous number of elements on with the same distance, we found one more element, so I will just increase the count. So I will make it as 2. So that means we have two elements at a distance of 8 from a point p1. Okay, which is that is p2 and p4. Let's go move on to the next one, that is p5. Okay, so what's the distance of p5 from that of p1? That is basically 4. Okay, so what I will do, I will see in the map and I found that 4 is already present and the value is 1. So what I will do, I just found a new element which also have a distance 4, so I will increase the count by 1. So basically what it does is, it just we just counted the elements with the same, you can say, distance. Let's say I make one more element here and name it as p6, and the distance of p1 to p6 is, you can say, let's say 3. Okay, So what I will make it here, I will make an another entry because no one is there with a distance 3. So I will make another entry with a value of 3 and assign a value of 1. Okay, now I have to find a boomerang. So basically the keys are representing the distance and the uh, values are representing number of points with that distance. Okay, so basically this is the stuff. So so now we can see how we can find boomerang from this particular map. Okay, so let me tell you how we can do that. So let's say for a boomerang, as we know from the question, for a boomerang we have 3 points, that is I, J and K. Okay, I, J and K. Okay, so I just made only this map is only for a particular point P1. So what I am doing here, I am telling you how many boomerangs can be made if I fix the point P1. Okay, so here you can see from P1, that is distance, at a distance of 8 there are 2 points. Okay, so this I is basically P1, and from P1 there are 2 points. What are the points? P2 and P4, which are at a distance of 8. So I will make, let's say I will make this as P2 and this as P3. Okay, but as I told you earlier, the order of the tuple matters. So it can be possible that it is P3 and it is P2. Okay, so basically there are two boomerangs. One is P1 P2 P3, other is P1 P3 P2. So this is the two boomerang at a distance of 8. Okay, similarly I can make same again, that is I, J and K. Okay, now if I check, I am checking it for the distance of 4. So this element is P1. Here the J is what? Here the J is P3 and P5. Okay, let's say this is for the first time it is P3 and it is sorry, uh, it is P3 and it is P5. Okay, it can be possible it is P5 and it is P3, as it is mentioned order matters. Okay, so so there are two boomerangs. How it can be two? The first one is P1 P3 P5, the second one is P1 P5 and P3. So there are two boomerangs from this. Okay, there is one more distance we have in our list, in our map, that is of 3. Okay, so let's take that case also. So there will be 3 points I, J, K. Okay, so the ith one is what? It will be P1, and the jth one is what? The jth one is, there are 1 point, so the 1 point is P6. Okay, so that is P6. But what about K? We don't have any point at a distance of 3 to be putted on K. Okay, and we know a boomerang will only made when we have 3 points, and that should be with a certain criteria that ij distance will be equal to ik distance. But here we not have 3 points, we only have 2 points, so we can't make a boomerang from it. Okay, so we'll not consider this. There are 0 boomerang from this. Okay, at a distance of 3, and there are 2 boomerangs at a distance of 4. There are 2 boomerangs at a distance of 8. Okay, so this is like how the stuffs are going on. Let me uh, So let me also explain you first example using the same how the answer is coming. So here there are 3 points 0 0 1 0 2 0. Okay, so I will make it for the 1 0 only. 1 comma 0, let's make the map. So we have to make the map for all, like 0 comma 0 1 comma 0 2 comma 0. We have to make the map for all. Let me make the for all, so it will be clear. Okay, so from 0 comma 0, the distance of 1 comma 0, okay, will be what? Let's say we are taking 0 comma 0. That means basically the value of I is 0 comma 0. Now we have to find the value of j and k. Okay, so what our approach is saying, we will go to each point and we will find the distance of that particular point, and we will put the count how many points are coming onto the same distance from our ith point. Okay, so what we will do, I will go to the ith, that is from 0 comma 0. I will check the distance of 1 comma 0, so that will basically 1. Okay, so from 0 comma 0, the distance that is 1, there is a element 1, means there is one element. Okay, now check from 0 comma 0 the distance of 2 comma 0. Okay, so that will be 2. So from 0 comma 0 at a distance of 2 there is also one element. So this is basically the map. Or if I see how many boomerang can make or make from it, so as I told you earlier, I j k, so I is basically 0 comma 0 in this case. Okay, j, if I take j for the distance of 1, okay, so there is only one point at the distance of point, and if I put it on j, then there is no point, to put it on k, so which also have the distance of 1 from I. So as I told you earlier, there should be at least 3 points, so we can make a boomerang from it at a distance of 1. So let's check the boomerang of we can make a boomerang from I as 0 comma 0 at a distance of 2 or not. Okay, so if there is one point at distance of 2, let's say I put it on z, so there is no point remaining to put it on k, so we can't also we cannot also make a boomerang from this also. Okay, so uh, so there is no boomerang from point I 0 comma 0. Okay, so let's take then another point. Okay, so that another point is what? 1 comma 0. 1 comma 0. So we will similarly make the map. Okay, so that map basically consists a key as a distance and a value as a number of points having the same distance from 1 comma 0. Okay, so from 1 comma 0 the distance of 0 comma 0 is what? It is 1. Okay, so the distance 1, for the distance 1 we found one point. Okay, we found one point. Okay, so now check the distance of from 1 comma 0 to distance of 2 comma 0, that will also be 1. Okay, so that if that will also be 1, so we don't have, like, we will check there is already a point with a distance of 1, so we will increase the count, the count will become 2. So basically what this making us a sense is, there is a element. Okay, there are 2 points, at a distance of 1, so this is showing the distance, this is showing a number of points. Okay, so there are 2 points at a distance of 1 from I, or you can say ith point, or you can say the value of I as 1 comma 0. Okay, so now there is no point remaining, so to let us know how many boomerang we can make it from here. I j k. Okay, the value of I is here, the value of I is 1 comma 0. Okay, so from 1 comma 0 we have 2 points at the distance of 1. Okay, let's say the first point we may place it here, the first point, let's say 0 comma 0. Okay, if I place 0 comma 0 here, then for k I have the point 2 comma 0. Okay, so this is the first boomerang, 1 comma 0, 0 comma 0, 2 comma 0. From 1 comma 0 to 0 comma 0, the distance is 1. From 1 comma 0 to 2 comma 0, the distance is also 1. Okay, it can be also possible, so this is become the one boomerang. So it, but still it can also be possible the value of j can be 2 comma 0 and the value of k can be 0 comma 0. So it will also become a one valid boomerang because the distance of 1 comma 0 and 2 comma 0 is 1, and the distance of 1 comma 0 1 0 comma 0 is also 1. So it will also become a valid boomerang. So the two boomerang will be 1 comma 0 0 comma 0 2 comma 0 and 1 comma 0 2 comma 0 0 comma 0. So the total sum of boomerang will be 2 from a point I. Let's move on to the other point, that is, let's take I is equal to 2 comma 0. Okay, so from 2 comma 0, if we see the distance of 0 comma 0, so the from 2 comma 0 the distance of 0 comma 0 will become 2. Okay, as per the formula, distance between 2 points, we found the distance is 2. If the distance is 2, we found a 1 point at a distance of 2. Okay, now check from 2 comma 0 the distance of 1 comma 0. If we check that, we will found the distance of 1 comma 0 from 2 comma 0, that is 1. Okay, so we found a point at a distance of 1. So we have one point at a distance of 2, 1 point at a distance of at a distance of 1. And we know for making a boomerang we need I, j, k, that is 3 points. If I fix this particular I as 2 comma 0, then I want 2 points at a same distance to be putted on j and k. But if I see for the distance 2, we have only 1 point, so I can put it either on j or either on k, but one will remain unfilled, so it can't be make boomerang at a distance of 2. If I check at a distance of 1, so there is also 1 point, so I can also make I cannot make a boomerang with that also from a distance at a distance of 1 from 2 comma 0. Means there is no case to make a boomerang from 2 comma 0, or you can say fixing the value of 2 comma 0 as I, so there is 0. So from the all the 3 points, making that as fixed as the value of I and checking how many boomerang we can make, so the total count will become 0 plus 2 plus 0, that will be equal to 2. Okay, and that is our as per the example. So let us code it fastly. So okay, so before coding, let me increase the size. So here you can see, as I told you, I have to fix each and every point. Okay, to fix each and every point I have to loop over each and every point now. So I will loop over each point. So from point in point, for point in points, I will loop over each point, and on each point what I will do, as I told you earlier, I have a map. Like for 0 comma 0 I created a map of distance and a particular number of points. Similarly for 1 comma 0, similarly for 2 comma 0. So for each for each point I have to have some map. So let's say I just name it as a point, let's say point map. Okay, so this is the point. Okay, so next what I have to select one point. Here in this case we selected 0 comma 0, and then what we'll do, I just found how much distance this 0 comma 0 from 1 comma 0 and 2 comma 0, and then I just inserted that into the map and increased the count as per number of elements at the same distance. So the same process we will do it here. So I will found the distance of the other points. Okay, so let us say the other point at the second point. Okay, so let me increase, it will be easy to read. So the second point in points. Okay, so what I am doing, I have to find the distance. So the distance formula, as we basically know, is x2 minus x1 square and plus y2 minus y1 square to the whole under root. Okay, so we have to first find the difference of the x2 minus x1. So let me make it easy to, so basically point 0 minus the second point is second point, zeroth index. Similarly we can do it for y by just changing the index. Okay, so this is for y. So and now we are finding the distance, so the distance will become so as per the distance formula, that is under root of x square plus y square. So we will do the x square plus y square. Here I am not doing the square root, as we know if I have two values x square and you can say a y square, or you can say x to the power 1 by 2, or you can say x to the power under root. Okay, so I can square both sides and cut this 1 by 2, and I can say x equal to y. Similarly I am saying to find a distance from this element to this element, we are using the formula under root of x2 minus x1 square and plus y2 minus y square, and similarly we are using the same formula. So what I am doing, I am squaring for each point. So I am not considering square root for each point. If you want, you can use square root and import the math library, but I just want to decrease the operational cost, so that's why I'm doing this, so it will be much easy. Okay, so in the next step what we can do, uh, firstly I will check is there any element in our dictionary, or you can say in our map, that is we made it that is we created here, is there any element already present at the same distance. So I will check if the element not in this not in that particular point map dictionary, or you can point map, then what we will do, I will create an element, okay, with the distance of what we found, that is dist, and I place the initial value as 0. Okay, then what I will do, if the element is present, if the distance, or you can say the key as whatever the distance we find is present in the point map, if not, if that is not present, then I will create that key and put the value initial as 0. Then what I will do, whatever the value is, whether we are checking the second time, here you can see we are checking the second time, so we increase the value by 1. Okay, so similarly what we will do here, we will, whatever the value of dist, we will increase that by 1. Okay, now here we can see we will move on. Here we can, what we will do, we have to find for how many boomerang we made from that. Okay, here you can see I just go through, I just help you to go through a particular map and found how many boomerang we can make. Okay, so here you can see for key comma val, basically value in point map dot items. So basically what it is doing, it is basically giving us the key and value pair, and I am storing the key in key, value in val. Okay, so what I will do, okay, there is one thing we needed, we need result here. Okay, so what it, or you can say result as count. Okay, so what it will do, it will just count how many boomerangs are there. Okay, so what I will do, plus equal to, okay, here is one more interesting concept, that let's say there are okay, at a distance of 2 for any element, let's say I, at a distance of 2 there are 4 elements. Okay, so that what that means I j k, so the first point will be I, and from the 4 points, let's say the 4 points are a, b, c, d. Okay, so it can be possible it will be a and it will be b, but it can also be possible na, it can be e, it can be c, it can be possible, it can be a, it can be d, it can be possible, it can be b, it can be a, it can be possible, it can be b, it can be c. So there are number of combinations you can make from this 4. Okay, so as per the permutation combination, we know if we have two spaces, this is the first, this is the second. So if we have two spaces and we have some certain amounts of items, then we can find how like how many possible number of permutations of that. Okay, so for 2 points we can see, if we want to fill 2 points, then we can say for the first point I can make four choices, that is I can put either A, B, C or D, and for the next one I will remain with 4 minus 1, that is three choices, because I use the one here. Okay, so I have four choices here, three choices here. So the total permutation will become 4 into 3, that is 12. So there are 12 number of ways to put values here. So that will become 12 boomerangs, because there are 12 different combination with I you can make. Similarly, you can see we can make this and this. So we are making two combinations, so we are saying two boomerang. So similarly, we are making 12 combinations, so we are saying 12 boomerangs. Okay, so what we can conclude it here. So whatever the number of possible outcomes we have, okay, whatever the number of possible points we have to fill it on the place of j and k, so to find the boomerang, what we can say, the number of points we have, let's say the number of points we can fill is k. Okay, so the number of points we can fill k into k minus 1. Similarly, you can see the here the number of points is 4, so it is 4 into 4 minus 1, that is 3. So this is basically how we concluded number of boomerangs as per the number of points we have to fill at that particular 2 points. Okay, so basically what it will come, it will val, or you can say if you are going as per the variable I took there, so you can take it as k, that will be k into k minus 1. Okay, so what it will do, it will just calculate all the number of boomerangs for that particular ith value, and it will just add it into the count. So for each ith value, whatever the number of boomerang we are finding, we are just adding it and adding it into the count, and at the end what we will do, we will just return count. Okay, so let's test it for the test cases. Okay, so let's test it for the test cases. Okay, so let's test it for the test cases. So here you can see it is passed. So let me submit it. So here you can see it is passed with a 98.15 percent less memory than other, and 72.98% speed than as compared to that of others. So here it is all about that number of boomerangs problem. So we'll meet in other video with other LeetCode problem, or some other coding platform interesting problem. So this is all about number of boomerang problem. We will meet in other video with some interesting problem. So this is all about LeetCode. Uh, so this is all about number of boomerang problem. We will meet in next video with some interesting. Uh, this is all about number of boomerang problem. We will meet in next video with interesting. This is all about number of boomerang problem. We will meet in next video with other interesting problems. Thank you.